You walk into a dealership, open a new imported car store, and everything feels untouched. The paint is flawless. The interior still has that new car smell. It seems as though the vehicle traveled directly from the factory to the showroom. But before it reached you, it was likely parked inside a ship with more than 10,000 other vehicles. If cars are loaded in the wrong order, the ship can arrive at its next port with the vehicles it needs physically trapped behind thousands it is supposed to keep aboard. This pure car carrier is 750 feet long and 130 feet wide, with 14 vehicle decks and a capacity of 10,800 car equivalent units. That capacity assumes a standard size, but the cargo mix changes. Compact cars, SUVs, and heavy construction vehicles consume drastically different area, height, and weight. Every voyage creates a physical sequence that must be dismantled at several different ports, perhaps stopping in Belgium, then Britain, and then the United States. A car for the first stop cannot be buried behind those intended for the last. Delivering a flawless vehicle requires managing thousands of interdependent physical variables through a confined space. The solution begins before the first engine is started. Planners convert the physical ship into a zoned digital map. This wireframe model shows the plan's required inputs: structural limits, vehicle dimensions, weight, quantity, and port sequence. Hyundai Glovis uses an AI-based stowage system to map routes and height restrictions, reducing a 27-hour planning process by roughly half. A bad plan creates a physical bottleneck. If the wrong cars are at the front, crews must unload, store, and reload hundreds of vehicles, multiplying the time spent at the berth and increasing the opportunity for damage. Near major automotive ports are enormous vehicle terminals filled with rows of new cars. These terminals function as sorting machines. Every vehicle is inspected, tracked, and positioned in designated blocks to match the ship's precise loading order. The stationary cars on the dock are already part of a rigidly controlled handoff between the factory and the final destination. When the vessel arrives, the digital plan becomes physical traffic. Drivers take each vehicle up a massive external ramp, a process known as roll-on, roll-off. Inside, the driver enters a windowless network of ramps and marked lanes. The interior functions as a tightly controlled urban road network. Small mistakes propagate quickly. A stalled car on a ramp can stop every vehicle behind it, and a driver entering the wrong deck can obstruct an entire loading team. Vehicles must clear the entire sloping driveway, not just their final parking spot. This requires strict rules, such as a 5-centimeter clearance from the deck ceiling and reduced speeds in tight passages. The ship physically adapts to its cargo using liftable decks. On the Glovis Leader, 5 levels can be repositioned to maximize space for standard cars or create the height needed for buses and machinery. Weight limits also dictate the internal geometry. Planners manage individual wheel and axle loads so that the weight concentrated in small tire contact areas doesn't compromise the deck structure. As thousands of vehicles move aboard, the ship pumps ballast water through dedicated tanks. This maintains stability and protects the external ramp hinges from damage caused by the vessel leaning. Loading is an ongoing act of teaming chaos, requiring operators to balance rigid geometry, high-volume traffic, and shifting weight distribution. Once the ship departs, the stationary floor begins to move. The vessel pitches, rolls, and accelerates as it encounters ocean waves. A parking brake cannot hold a 2-ton vehicle against these forces. Cars are secured to deck fittings using specific lashings and wheel wedges based on their weight and orientation. The voyage requires a continuous inspection loop. Crews check for loosened lashings or fluid leaks upon departure, daily for the first 3 days, and every 3rd day afterward. Fire is the most significant threat inside these enclosed decks. Smoke and heat can spread through a large space before a crew member can physically locate the source. International safety rules implemented in 2026 mandated stronger protections, including fixed detection systems, alarms, and continuous video monitoring of all loaded vehicle spaces. Electric vehicles have specific safety layers. Operators impose battery state of charge limits and prohibit charging high-voltage batteries during the voyage. With the external ramp closed, the ship enters a state of total containment. Every safety system is focused on monitoring the internal environment and suppressing any threat to the cargo inside. At the first destination port, every decision made during the planning phase is tested in reverse. In a successful plan, the designated vehicles form an orderly stream down the ramp, while cars meant for later ports remain secured and out of the way. Once ashore, the cars enter the final terrestrial chain. Destination terminals inspect, clean, and prep the vehicles for final transport via truck or train. The buyer at the dealership receives a clean car and a set of keys, unaware of the massive logistics chain that preserved the vehicle's condition across the ocean. The immense size of a car carrier is its primary vulnerability. The operation only succeeds by maintaining absolute, unrelenting control over these thousands of interdependent variables.